In part 1, we saw how to use multiple arrays and debug problems when we accidentally have arrays of different sizes. Now let's make the program a little more interesting. Let's move the circles up and down. So I'm going to give every circle a center. And just for fun, I'm not going to set the values for Y center up there. I'm going to just do it the other way. I'm going to do it the slow way. So I've declared Y center. Now I'll allocate it by saying Y center equals new float. And I want as many entries in Y center as I have in X center. And X center has already been brought into existence because it's a global variable. So it gets built before setup even gets called. So I know I can call X center.length. And now I'll write the same sort of loop that we have below. I equals 0. I is less than Y center.length because now we have a Y center. I plus plus. And I'll say Y center sub I equals height over 2.0. So it's exactly the same position that we had before, but now I can change them. So I'm going to copy that. I'm going to paste it on top of height over 2. So now my ellipse will be at X center sub I, Y center sub I. Let's run this. And if I haven't messed up, beautiful. So now let's make the circles move. So I'm going to create another array up top, and I'm going to call it Y move. And I'm going to move the circles up and down. And I don't know how much to move them up and down, so I'll just guess at some numbers. It'll be that many pixels per frame. After I draw each ellipse, I'll say Y center sub I plus equals Y move sub I. And let's see how that looks. We'll run it. Whoa, okay, that was way too fast. Tell you what, let's divide everything by 10. So 30 becomes 3, 20 becomes 2, 10 becomes 1, 35 becomes 3.5. Maybe that's going to be too slow. It's okay. But now they're flying off the top and bottom of the screen, and that I don't want. So I'm going to put in a test, and I'm going to say if, and I know something's going to go in here that says if I'm off the top of the screen or I'm off the bottom of the screen for this given circle. So if I am off the top or the bottom, and I'll fill those in a moment, what am I going to do? Well, I'm going to turn the direction in which I'm moving around. If I'm moving up, I'll move down. If I'm moving down, I'll move up. So I'll say Y move sub I equals minus Y move sub I. And this is such a common thing. You'll often see people do it this way. Y move sub I times equals minus 1. And that is the same, you'll recall, as Y move sub I equals Y move sub I times negative 1. That just reverses the sign of Y move. If it's 3, it becomes minus 3. If it's minus 3, it becomes positive 3. But we're not going to use that. This is another perfectly valid way of writing that. And now the circle is already off the screen, right? The test is finding out if the circle is off screen. So I have to bring the circle back onto the screen. So I'm going to add Y move back in, but I'm going to add in 2 times Y move. And that's going to bring my circle not only back on screen, but it's going to give it a nudge in the direction I want it to move in. You can see that I've forgotten to add in twice the new value of move. I'll come back and fix that later. So what are my 2 tests? Well, let's see. If Y center sub I minus radius sub I, that's the top of the circle. So if that's less than 0, or, well, the bottom of the circle is the center plus the radius. So I test if that's greater than height. All right, let's see how that works. Oh, and I have a problem. I forgot to put sub I at the end of radius. I'm getting this weird error message. The operator plus is undefined for the argument types float, float. That actually makes sense if you think about it and you try to work it out. But, you know, it's easier just to look at the line and say, hey, I forgot the brackets. And now it's saying, cannot find anything called Y move. But I know I have a Y move, and oh, I need to have a capital M. All right, let's run that and see how that works. Well, isn't that sweet? So we're using multiple arrays, and again, if Y move wasn't big enough, we would be getting an error. So we have to make sure we have at least as many entries in Y move as we do in the other arrays. Tell you what, for fun, let's change the radius too, just to kind of up the ante. So I'm going to create another array, and I'll call it R move for radius move. Maybe R change or something would have been better, but let's try this. And this is how many pixels the radius will change by on every frame. Tell you what, let's make this one negative just so we have positive and negative. And in here we'll say radius sub I plus equals R move sub I. So now in every frame the radius will change. Let's see how that looks. Oh, okay. those numbers are way too big. Things are getting way too fast. Let's try chopping these down by a factor of 10. Let's see how that looks. Okay, it's still way too fast. Let's chop them down by 10 again. We'll just divide everything by 10 here. Ah, there we go. Okay, now things are looking good. But you can see what's going to happen. This big circle is getting bigger and it's just going to explode and eventually it's going to cover the whole screen. So you know what I'm going to do is I'm going to say when we bounce off the top or the bottom of the screen, we're also going to change the sign of our move. So if the ball is getting bigger, then when it hits the top or the bottom of the screen, it'll get smaller and vice versa. So all I have to do is change the direction of our move. Whoops. And I'll do the same thing with radius. I'll correct radius just like I corrected Y center. And let's run that. And we have a problem. I forgot the capital M again. Still a problem. I forgot the capital M in both places. All right, let's run it. Whoa, okay, something really went wrong. Oh, I said radius sub I plus equals radius sub I. But what I wanted was 2 times R move sub I. And in fact, I wanted 2 times Y move also. So let's run that. Okay, let's watch the third circle from the left. It's getting smaller and smaller and smaller as it goes to the down, hits the bottom, and now it's getting bigger as it works its way up. Hits the top of the screen. All right, so this is everything I wanted. So this is the beauty of using arrays. You just have a bunch of numbers and every element in the array gets treated the same way. We have 4 balls. We're treating each of the balls the same way, and it can be a very complicated bunch of stuff to do, but it's the same for every ball. And just to sort of cement this, let's add one more entry to the array. So they don't have to be sorted. I just happened to have sorted the centers. So I'll stick the last one in the middle. And now I have to make sure that I put in another entry for all the other arrays, or I will get that error again. So what should the radius of this one be? I don't know. We'll start it off somewhere in the middle. Y move, let's make it move the opposite, but fast is the last one. And let's make this one move really, change the radius really fast. Maybe minus 0.4. So now we'll run the program again. And we have one more circle. And it's bouncing up and down, and it's moving fast, and it's just what we wanted. So this is an example of how to use arrays. Now, you can do a ton of additional things with this, of course. These things can be moving horizontally. They can be bouncing off of all kinds of things. They can all have different colors. The colors can be changing. Maybe when 2 balls collide, they trade colors and bounce off of one another. Or maybe when they collide, they exchange just the red parts of their color or just their hues. So there are lots of things that you can do to extend this program if you feel so inclined. The important thing is you can use lots of arrays simultaneously. You'll always have a for loop that is running through one of the arrays. And typically you'll use a little throwaway variable like the letter I, and I'm using here. As long as all of your arrays are long enough that every value of I is valid in your array, then everything is going to work beautifully. If one of the arrays is too short, you'll get that error message, and then you just have to figure out which array is too short and make it longer. Keeping these rules in mind, you can create lots of objects that are changing in time in lots of interesting ways.